Alright, what's up guys? Back at it again with another math tutorials. Second video of the day, like I promised, and we're just gonna get straight into it. This is another AP Calculus BC practice problem for my homework. Alright, so the velocity vector of a particle moving in the plane has components given by a bunch of stuff. Great. They give us, crucially, they give us dx dt and dy dt and an interval for t. But they do not give us the actual functions relating x and t or x and y or anything. At time t equals 0, the position of the particle is negative 2, 3. For this interval, find all values of t which lie tangent to the path of the particle's orbital. So we're talking about the slope. And so for that, we need dy dx. Now we have dy dt and dx dt. So if we go dy dt over dx dt, the dt's actually cancel out, and that equals dy dt. So let's do dy dt over x dt, dx dt. So we have 1 plus sine t squared divided by 14 cosine t squared sine e to, okay, great, whatever that means. Cosine, what did this say? Okay, t squared times sine e to the t. Alright, so this is how you know it's a calculator problem. One, the fact that it says calculator right there. Two, the fact that it's got all this dumb stuff in it. And if it wasn't, this would probably be like from 0 to pi or something. Anyways, so we want, I wish the line tangent to the path is vertical. So for a function to have like a vertical tangent, that was terrible. A vertical tangent, that means that the slope has to be undefined at that point. Because it has to be like something over 0, basically. So we want this to equal 0. So we have, this is already factored. So if either cosine t squared is 0 or if sine e to the t is 0, either one is going to make the whole thing 0. So let's say cosine of t squared equals 0. And then we'll go sine e to the t equals 0. Oh, okay. So for cosine to be 0, it's got to be, even circle, x is 0, it's got to be either up here or down here. So let's say t squared equals pi over 2, or t squared equals 3 pi over 2. Of course, it can't be negative because we're squaring it. And anything more, it's probably going to take t to be greater than 1.5. We want only from 0 to 1.5 or 2. So we're basically looking at t equals root pi over 2, and t equals root 3 pi over 2. Now, let's see if any of these are usable. So second root, I'm on my calculator right now, breaking the fourth wall, pi over 2, root pi over 2 is about 1.2. So this is approximately 1.253, and this one is approximately, let's see, 3 pi over 2. Ooh, sorry guys, approximately 2.171. So that means that that is greater than 1.5, so only this is usable. So t has to equal root pi over 2. Okay, any other values? Well, sine e to the t equals 0. So we want, unit circle, we want sine to be 0, so we're talking either 0 or pi. So we're talking about e to the t equals 0 and e to the t equals pi. This does not work. You would go natural log both sides, I think, right? So you would end up being t equals natural log 0, and natural log 0 doesn't make sense. And that makes sense because no matter what you put here, even if you put like a super negative number here, it's just going to be 1 over some really big number, and it's never going to equal 0. So this one makes no sense. This one, on the other hand, like I said, you would take the natural log of both sides, and you would end up with that kind of cancels out to just be t equals natural log of pi. Now let's see if this is viable. What is the natural log of pi? Any guesses? I'm guessing 1.2. 1.14. 145. So that is usable. So we have these two values for t. I suppose I'll write it down. T equals, oh, I'm not going to remember this. 1.253, 0.253, or it can be 1.145. 1.145. Let me just check the answer key. Make sure that's actually right. 1.2. Yeah. Okay. Yep. Got it. That is correct. Okay. So, did part A. You know what? Let's cross it off just to make ourselves feel better. It's very important during a test. You want to make yourself feel better about stuff. Write an equation for the line tangent to the path of the particle at t equals 1. So, first thing I'm noticing here is we want an equation for the line tangent to the path. So, we're most likely going to end up using point slope form, which is y minus y1 equals mx minus x1. I think that'll be most useful, but also we're asking for t equals 1. We have the coordinates for t equals 0, so that sucks. Because we need two things for this. We need a point and the slope. The slope is going to be easy because we have dy dx right here. We already know that equals this whole thing. So we can just plug in 1 for that. I'm not concerned about that. The point will be more difficult though. So my plan for that is to take the starting point. So let's say we're doing the x, right? Take the x and then the starting x from t equals 0 and then add the integral of the time from 0 to 1 of the dx. So 14, well, okay, of dx dt, right? Because the thought is that that will tell me how much it changed. Because I mean, actually, I don't even know if this is like allowed, but it kind of makes sense in my head. When you do an integral, you have the dt here, and these kind of cancel out and just leave dx, and that means change in x. So you have -2, the starting x, plus the change in x should give you the final x at t equals 1. I don't know if that's actually how the like dx dt stuff works, but it kind of makes sense in my head, so I'm just going to roll with it. And then you can do the same thing with the y. So I'm going to write the equation before plugging stuff in. So like I said, y minus y1 equals x. Nope, that's not right. Mx minus x1. So the y minus, so the y1, we're going to do this kind of sort of thing right here. So the starting y is 3, and then we're going to add the integral from 0 to 1 of this. So 1 plus 2 sine t squared. 1 plus 2 sine t squared dt. Okay, and then so that's that side equals, so m is going to be the slope, which is going to be this whole thing at, while plugging in 1 for t, because this we know at each particular point, so we can plug in 1 for t there. So that's going to be 1 plus, what is it, 2 sine 1 squared, which is just 1, of course, so 2 sine 1 over, what was it, 14 cosine 1 sine e to the 1, so just sine e. So that's m times x minus x1, which is going to be -2 plus the integral, wow, that was bad, integral from 0 to 1 of the dx dt. Wow, no clue where I am on this thing. Oh, right, that's the 14 cosine t squared sine e dx. So 14 cosine t squared sine e to the t. Right. Okay, so, and this is it, guys. This is our final answer. So I assume they kind of wanted a little bit simpler than that. Um, this is pretty much what I wrote exactly, but then I figured it's a calculator test, which means they probably want you to like plug some stuff in and get some like actual values, which they don't actually say, they don't really make clear. So I kind of feel like this should be an acceptable final answer for part B. Um, but I might as well do some calculator stuff just because we have the power. So I'm just going to plug this into the calculator. So that's going to be 3 plus math fn int 0, 1, 1 plus 2 sine x squared dx. So y minus 4.621. Let me just make sure that checks out with the answer sheet so far. It does. Equals, what is this? 1 plus 2 sine 1 divided by 14 cosine 1 times sine e. That comes out to about, oh, forgot how to draw, 8, nope, 0.863 times x minus, what's this one? Negative 2 plus math fn int 0, 1, 14 cosine t squared times sine e to the t, or an x in this case, I guess, because we're doing on a calculator and the variable is x, minus 9.315. So now I'm going to hope that that's the same as the answer. Yes. Okay, so, and then of course you could kind of just add this to the other side, but this should be an acceptable answer as well. Um, so it's not too hard. It's just like kind of ugly to look at, but then you plug in some calculator stuff to make it a lot easier. I'm not going to rewrite it up here. I'm just going to cross out. Find the speed of the particle that's equal to 1. Now we have an equation for speed. So speed is basically root this squared plus this squared. So basically root dx dt squared plus dy dt squared. That's what speed is, which kind of makes sense. You think of these as two really small little vectors, right? And then like the speed kind of is just like this part right here, right? Absolute value type thing, Pythagorean theorem, something like that. But at t equals 1, that shouldn't be too hard. I should just be able to plug in 1 for this and this and this and just plug it into this formula right here. So I guess I'll write that out, even though it's probably going to be kind of annoying, but whatever. So that would be root, I think I have it memorized at this point, 14 cosine 1 sine e squared plus 1 plus 2 sine 1 squared. Let's see what this gives us. Equals, that was a great equal sign. I'm really putting my calculator through it right now. I mean, these aren't that hard. The one of them did take a little bit of time to process, but I have a nice calculator, so you'd think it wouldn't really take that long, right? And I think probably mine does it quicker than a lot of things would. 1 squared. So that's giving me about 4.105 as the speed. Let me check if that's the right answer. It is in fact the right answer. So that was pretty easy. Now find the acceleration vector at particle t equals 1. So these are all velocity vectors. These two things right here. So we want to take the derivative of these, which is unfortunate, to be honest, but shouldn't be too hard. So let's rewrite these in their actual forms. So it's 14 cosine t squared sine e to the t, and then it's 1 plus 2 sine t squared. Okay, so we want the derivatives of these basically. Although, I believe you can kind of just let your calculator do this. Right, there's a derivative button, and this is a calculator test, so why waste time, right? So yeah, okay. So calc n deriv. So I went to the math and clicked n deriv. So now I'm putting in I'm putting x as my variable of differentiation, or whatever it's called. I'm just gonna write in 14 cosine x squared times sine e to the x. And then I'm just gonna say x equals 1. See what this gives me. Negative 28.425. And then let's try the same thing with this. Why waste time on a calculator test, right? X, put in the function 1 plus 2 sine x squared. X equals 1. 2.161. Now, I didn't learn any sort of fancy like velocity or like acceleration vector notation when I took physics, but I guess it exists. I don't know. But I don't know. I'm just gonna write it like this. 28.425, 2.161. I think they write it as more like that, but I don't know. I don't even know HTML. So yeah, and that is the right answer. So basically, just had the calculator do that one for me. Kind of lazy, but let's be honest, nobody wants to find derivatives. Nobody likes doing the product rule and the chain rule and stuff. So yeah, that's pretty much the end of this problem. This one's definitely an easier problem, I think. I think the hard part, honestly, was probably this equation. Just figuring out, I think this part really, figuring out that you had to find the position at t equals 1 by finding it at 0 and then adding the change in position from 0 to 1, right? But I think that kind of makes sense. You just kind of have to know how to use the integrals in that way. But other than that, it's probably not too hard. Hopefully you guys are able to follow it. If you have any recommendations for what I should have done better, let me know in the comments. Other than that, stay tuned for next week. Maybe I'll have my ACT squared by then. Who knows? But see ya. Hopefully I won't forget.